quick example on how we can apply proportional relationships for similar solids. What's on the board right now? The water dispenser at an office uses paper cups in the shape of cones to serve water. Remember how you kind of go up to a water tank, you pull out a paper cup, you fill it, you take a drink? That paper cup is a cone. Sometimes it's like a little Dixie cup. Though.
I know, but sometimes they're just cones or like that.
So we're going to use cones in the shape, use paper cups in the shape of cones to serve water. Each paper cup has a maximum diameter of 6 centimeters and of a height of 11 centimeters, like you're seeing here. Of course, are you going to fill that entire cone cup with water? No, right? Because aren't you just going to spill it, make a big mess, and fill it all the way to the very, very top? So you fill the cup to 75% of its height to prevent spilling. I don't want to fill it all the way up, so I just fill it up to 75% of its total height. So I put that little water level right here. 75% of the way up, 75% of the total height of 11 is where I filled the water to. How much water did you put in the cup?
75%.
33 pi.
How much water was put in the cup if I filled it 75% of the way to the top? Right? Let's think about what the maximum volume would be if I filled it all the way up to the very, very top of the cup. What would the maximum amount of water be in the cup? What is the maximum amount of volume that the cup would contain?
8.25.
How do you find the volume of a cone? What formula would that be given?
1/3 of pi r squared.
So try this, Stephen. Since we've got this cone here, what's the radius and height that we've been given? 3 and 11? Let's just type that into a calculator. Let's see here. 3 squared would be what? 9? What's 9 times 11?
I got it. I thought you left.
Yeah, meeting. A third of 99 pi. 3 squared times 11 makes 99, so I'm left with a third of 99 pi. Actually, what's a third of 99? What's 99 divided by 3 when I multiply these two together? So I'm going to have, in exact form, 33 pi cubic inches of water. I have an exact volume of 33 pi cubic inches of water. Or if I want to use that as a decimal, 33 pi is about 103.7. Okay. So would it be as simple as just taking 75% of that number?
No.
Here's a common mistake. Is it as simple as just taking 75% of that number?
Yes.
I wish, right? That 75%, is that the scale factor, the area ratio, or the volume ratio? Think about what this is related. 75% of its height between the entire cone versus the amount of water that the cone is filled up to. That's a ratio of height, isn't it? It's a pair of corresponding lengths. The height of the water versus the height of the cone, that's in a ratio of 75%. That's a ratio of lengths. I want to compare the volumes of the water that's in the cone with the volume that the cone could possibly fill up. So my scale factor is 75%. What is that as a fraction?
3/4.
The scale factor is 3 to 4. 3 to 4 is the relationship between the height of the water in the cone versus the height of the cone itself. If the scale factor is 3 to 4, and I want to compare the volume of water in the cup versus the volume of the cup itself, what do I have to do to this given scale factor? What's the relationship going to be when I compare these two volumes together for cone versus cup of water?
27 to 64.
Second again,
27 to 64.
how you doing that?
I just took 3Q and got 27.
Right. I have to compare the right proportions. I'm trying to relate the volume of water in the cone versus the volume of the cone itself. So it's not just like taking 75% of this, because that's not relating the same type of things together. This is the relationship for the lengths. I'm trying to figure out the relationship for the amount of volume. So like AJ said, the volume ratio is 3 cubed to 4 cubed, which is 27 to 64. Guys. Now, just like you practice over here, let's make a proportion. Which ratio do I want to use? 3 to 4 or 27 to 64? One more time, just make sure you got it. Why, Steve?
Because it's the volume.
I'm trying to relate the volumes together. The volume of water in the cone versus the volume of the cone itself. If I use the scale factor, I'm not comparing the right proportions, because this is the ratio of lengths for the scale factor, not the ratio of volumes that I'm trying to relate together. So make a proportion. 27 is to 64 as what is to what? Right, you could use 33 pi or about 103.7. I'm just going to use 103.7. Why'd you put X on top? Explain, Mark.
Because we don't know what 75% of 3.7.
Right, isn't there less water in the cone than the cone itself?
Yeah.
So I'm looking for a smaller volume compared to the overall volume, the volume of the cone itself. Now let's just cross multiply and go. X times 64, 103.7 times 27. It's approximately 2,799.9. So divide by 64, as I solve this quick proportion. It's about 43.75. Yeah, go ahead.
Another question about the first one.
Mhm.
So when you set up
Sorry, Michael, I can't quite hear you because people are having conversations.
you set up the equation by simply squaring that.
Because the formula for the volume of a cone is 1/3 pi r squared times h. 6 is the diameter. That's all the way across the circle of the cone. I want half of it for the radius. Does that sound right now? 43.75 after I solve the proportion. Inches cubed. I was just going to answer that. What's the label? Cubic inches. Oh, centimeters. Thank you. Metric units. There's inches over there. I had inches on it. Okay, and we get that scale factor. How'd you get the scale factor? Good. We're going to fill the cup to 75% of its total height. So the height of the water in the cone versus the height of the cone itself, the whole cup, 75%. What's 75% as a ratio, as a fraction? 3/4. So when I compare the height of the water versus the height of the cone, that's in a ratio of 3 to 4. Of course, those are not the right proportion to use, right? Because I need the volume proportion to relate those two together, right? Yeah. Good questions. Excellent, excellent, excellent. Did I get anything else cleared up? Did I get anything else cleared up on that? Okay, then let's do this. You've got a couple of things to work on. Why don't you go ahead and grab